you need to practice taking derivatives? Well, that's exactly what we're going to do today. Let's get started. We're going to work through these derivatives very quickly. My advice, though, is to pause the video at each new page just to work those before we work them together and see how you do. All right, let's get going. So we have g of x is 2x squared minus 5x minus 3 times cosine x. If I'm taking the derivative of this, I have to do product rule because I have two functions being multiplied together. Product rule says first times the derivative of the second plus the second times the derivative of the first. So all I have to do then is to write the first times the derivative of the second, which is negative sine x. Make sure you put the parentheses to denote that you're multiplying those two things together, not subtracting. Plus the second times the derivative of the first, which is 4x minus 5. That's just a simple power rule. And there we have it. There's not much to do other than we might put the sine x first, but other than that, there's not much. So now we're going to move on to the second one. We have options here, actually. We could use quotient rule, or we could apply a clever algebra trick. Because remember, I can break this up as three different expressions. This only have one thing in the denominator. And the square root of x is x to the 1/2 power. I think that's useful here. And so if I do that, before I even take a derivative, I can simplify my terms. Because when I divide by x, I just subtract the exponents. So this is x to the 4/2 minus 1/2 for the first term, x to the first minus the 1/2, and then bringing the 1/2 up to the numerator in the third term, I get 4x to the negative 1/2. So now it's the derivative of that is just power rule. So that's 3/2 times 3, subtract the power by 1, 1/2. Then I get minus 4 times 1/2, which is 2, x to the negative 1/2. And then plus, because that's negative 4 times negative 1/2, we get positive 2, x to the negative 3/2. And there it is. Now you may have used quotient rule. So with quotient rule, it'll look something like this. Quotient rule says low d high minus high d low all over low squared. So here that would be low, which is the square root of x, times the derivative of the top, which would be using power rule, 6x minus 4, minus the top, which is 3x squared minus 4x minus 4, times the derivative of the bottom. And now remember, you have to remember that the square root of x is x to the 1/2 power. So that derivative is going to be 1/2 x, subtract the power by 1, negative 1/2, all over square root of x squared, which would just be x. If you want to know how to simplify this, you can multiply everything in the numerator by basically the square root of x, and then the denominator by the square root of x. And so if I do that, distributing across, I have square root of x times the square root of x, my first term, that just becomes x. So I end up with 6x squared minus 4x. I get an x times that stuff I went in and distributed. Across the second term, x to the negative 1/2 times x to the 1/2 is just 1. So I end up with just 1/2 times these other things. And then in the denominator, I end up with x to the 3/2 power. I could distribute the 1/2 and add my like terms and get a little bit more simple, but for the time being, we're just going to leave it like that. All right, so our third one. This time we do have to use quotient rule because I can't break up the denominator into three different parts. See, in the previous one, we only had one expression in my denominator, so I could break it up. For this one, I cannot do that. So I have to use quotient rule here. I'm going to leave the negative alone. And we said low times the derivative of the top, the derivative of e to the x is e to the x, minus the top times the derivative of the bottom, which would be 4x plus 1 using product rule, using power rule, I mean. And then the denominator, we have 2x squared plus x minus 4 quantity squared. And then it's a negative all of that stuff. And we can just leave it about like that. All right, let's move on. This time we have y squared plus y minus 4 all over y to the 1/6 power. I'm going to apply that same trick I did earlier. Since I only have one thing in the denominator, I want to avoid quotient rule if possible. I'm going to break this up as y squared over y to the 1/6 plus y over y to the 1/6 minus 4 over y to the 1/6. And then if I rewrite that, bringing my y to the 1/6 up to the numerator, that's y to the negative 1/6, and then combining my powers, I have y squared, which would be 12/6 minus 1/6. I have y to the 11/6 power. And then I have y to the first times y to the negative 1/6. So that'd be y to the 5/6 power. And then minus 4 y to the negative 1/6 power. So now when I apply power rule, I get 11/6 y you got to subtract, let's see, 11/6 minus 6/6. I get y to the 5/6 power. Plus 5/6 y to the subtract 6 from 5, you get negative 1/6 power. And then plus 4/6, which I know is 2/3, but we'll leave it like that. Subtracting 6/6 from negative 1/6, I get minus 7/6. So there's my derivative. Okay, moving on. We have negative 3w squared minus 6w plus 4 times e to the w power. So this is a classic product rule situation here. So when I take my derivative, don't worry about the negative. We'll multiply everything by negative 1 at the end. I have first times the derivative of the second. The derivative of e to the w is just e to the w. Plus the second, which is e to the w, times the derivative of the first, which would be 6w minus 6, just using power rule. So if I wanted to distribute the negative, I could actually factor out e to the w power. So I'm going to say e to the w times 3w squared minus 6w plus 4 plus 6w minus 6. Now I just can't help myself because the simplification of this is too good. I get 3w squared. Notice that I have a negative 6w and a positive 6w. Those subtract out. So I end up with negative e to the w power times 3w squared minus 2. Moving on, we have h of t equals negative 2 times t squared plus t minus 2 times log t. Again, product rule situation. So let's leave the negative 2 out of it. That is just a coefficient that doesn't affect our derivative, so we can multiply the negative 2 at the end. I use product rule. It says the first times the derivative of the second. Now, if you forget the derivative of log, that's okay. The easiest way to remember that is log base a through change of base formula. You can change your base to anything you want. I'm going to use the natural log. It's the same as natural log of t over natural log of a. Natural log of a would be a constant. And we know that the derivative of natural log of t is just 1 over t. So the derivative of log base a of t is going to be 1 over ln a times the derivative of ln, which is 1 over t. That's an easy way to remember it, is through change of base formula. So then the derivative of log t, that's log base 10, is going to be 1 over ln 10 times 1 over t. That's the derivative of the second. Plus the second, which is log t, times the derivative of the first, which is going to be 2t plus 1. Okay, now we probably should clean this up a little bit. I'm going to say, how about negative 2 t squared plus t minus 2 over ln 10 times t minus 2 log t times 2t plus 1. So I distributed my negative 2, and then I put the stuff in the denominator the way it should go. Okay, I hope these are making sense, but we're going to keep moving. This time I have g of w is 4 cosine w plus 4 e to the w squared. So I think this is our first instance of chain rule. This is going to require chain rule because I have a function inside a function. So when I take the derivative here, I'm going to have the derivative of cosine is negative sine. So I have negative 4 sine w plus the derivative of e to the w squared. So I'm going to have 4. Let's see, the derivative of e to the u is e to the u times the derivative of its exponent. So that's going to be e to the w squared times the derivative of the exponent, which is 2w. So just cleaning this up a little bit, there's not a whole lot we can do. We'll just say 8w e to the w squared at the end of this. So I have negative 4 sine w plus 8w e to the w squared. We'll do some more chain rule in a little bit. F of t this time is the 4th root of t to the 7th plus 4 over t to the negative 2 power. Write everything as an exponent first. So t, the 4th root of t to the 7th power is the same as t to the 7/4 power. Please just get familiar with how to convert things to exponent form. It makes your life a whole lot easier here. And then 4 over t squared is t to the negative 2. So this is just simply an instance of power rule. So I have 7/4 t, subtract 1 from that power, so that's subtracting 4/4. I have the 3/4 power, minus 8 t, subtract 1 again, to the negative 3rd power. If you wanted to write it back in your radical notation, that's going to be the 4th root of t cubed, and then we can say 8 over t cubed. I hope that makes sense. Let's do another one almost identical to this, g of y this time is the fifth root of y to the fourth plus 9 over y to the fourth. So here I'm going to write that as y to the 4/5 power plus 9 y to the negative 4 power. So my derivative then is just simply power rule 4/5 y, subtract 1, I get the negative 1/5 power, minus 36 y to the negative 5th power. I'd have 4 over 5, the 5th root of y. Why is that? Because I have a negative exponent, brings it down the denominator, and it's a 5th root. So I have 4 over 5, the 5th root of y to the 1st power, minus 36 over y to the 5th. Awesome. We got to keep going. Let's go. This time we have f of x equals negative 4x minus 3 to the ax plus 4 all cubed. So this is a chain rule situation. So the way chain rule works, I kind of glossed over it quickly earlier, but if I'm taking the derivative with respect to x of some function with another function inside of that, what I do is I take the derivative of the outside function but leave the inside alone, leave what's inside the egg alone, but then you multiply by whatever the derivative of the inside is. So we say du dx. So in this case, 4x minus 3 e to the x plus 4 is the inside, cubed is the outside. So here I have negative 3, 4x minus 3 e to the x plus 4 quantity squared. That's just power rule. But now I need to multiply that by the derivative of what's inside. So that's going to be times the derivative of 4x is 4 minus 3 e to the x plus 0, which I'm not going to even write. There's my derivative. Now, keep in mind, we didn't just make up these laws. These are just the way math works. It's just the way the math points us. Remember, this is attached to a physical thing. These are the rates of change of these functions. So we can't just make up laws that we think should work or that are play nice. This is just the way they are. Okay, but we're practicing them. You guys are doing good. Let's keep going. So now we have k of w is 9 cosine w 7/5 power. This is another chain rule situation. K prime is going to be, the derivative of cosine is negative sine. So I have negative 9 sine, leave the inside alone. Now I multiply by the derivative of what's inside, which will be 7/5 w subtracting 1, which is 5 over 5. I get 2 over 5ths power. I guess I can just clean up my coefficients a little bit. Now, keep in mind that this w to the 7/5 power and this cannot interact at all because this guy is inside the sine function. This one is outside the sine function. I see that mistake sometimes, but you cannot do that. Okay, but we end up with negative 63/5 sine. Well, actually, I'm going to write the w to the 2/5 power first, then times sine of w 7/5. There it is. There's my derivative. We have another one very similar to this. F of y is negative 5 cosine 4y squared minus 3y plus 2. So my derivative here is, again, the derivative of cosine is negative sine, so I end up with positive 5 sine 4y squared minus 3y times the derivative of what's inside. So that's times 8y minus 3. And we might write this as, if I distribute my 5, I get 40y minus 15. All of that times sine of 4y squared minus 3y. Again, this is inside the sine function. So every once in a while I see people try to do product rule on this thing. That shows me a lack of understanding of what we mean by cosine. Cosine by itself means nothing. Cosine by itself is kind of like saying square root. You can't just do anything just with cosine. It's cosine of something. This time the 4y squared minus 3y plus 2 is plugged into the cosine function. So keep that in mind as you're working these. Next, we have k of w is w minus 1 over w plus 4 all to the 5th power. So this is a chain rule situation, but I'm going to have to use quotient rule as well. So first I take the derivative of the outside part, which is the 5th power. So I have 5 times all that stuff, now to the 4th power. Now times the derivative of what's inside, and the derivative of what's inside requires quotient rule. So that's going to be low times the derivative of the top, which is just 1, minus the top times the derivative of the denominator, which is just 1, all over the denominator squared. Now we could clean this one up a little bit because I want to point out something. So I'm going to break this down like this. I'm going to say 5 w minus 1 the 4th, w plus 4 the negative 4th, right? So because I multiplied those together, This is in the denominator here. I have a w plus 4 to the negative 4th power. And then as I distribute here, I distribute to 1. I can subtract, look, w minus w. Okay, that goes away. And then I have a 4 minus a negative 1. So I end up with a 5 in the numerator. And in the denominator, I have w plus 4 to the negative 2. So now, look, as I combine terms, I end up with 25 w minus 1 to the 4th. And in my denominator, as I multiply those two things together, my like terms, w plus 4, I can add the exponents together. I end up with a w plus 4 to the 6th power. So it simplifies like that. But this part here is a correct derivative. Okay, moving on, we have f of x equals the square root of cosine of 3x cubed plus 2. I'm going to recognize that this is cosine of 3x cubed plus 2 all to the 1/2 power, right? This is square root. So as I take the derivative, I have to use chain rule again. That's going to be 1/2 cosine of 3x cubed plus 2 all to the negative 1/2 power times the derivative in what's inside. You could write it like this if you want it, times the derivative of cosine of 3x cubed plus 2. And the derivative of cosine 3x cubed plus 2 is going to require chain rule itself. So I end up with 1/2 cosine 3x cubed plus 2 all the negative 1/2 power times the derivative of cosine is negative sine 3x cubed plus 2. And then the times the derivative of what was inside of that, which will be 9x squared. Okay, so there it is. There's not a lot you can do here. You could maybe say like negative 9x squared sine 3x cubed plus 2 all over 2 square root of cosine 3x cubed plus 2. See if you can figure out how we got from one step to the next. Okay, g of y this time is 2y cubed plus 1 over y squared minus 2 all to the 4th power. So g prime of y is going to be 4 2y cubed plus 1 over y squared minus 2 cubed. That's chain rule. Times the derivative inside, which again is going to require quotient rule. So that's low times the derivative of the top, which is 6y squared, minus the top times the derivative of the denominator, which is 2y, over y squared minus 2 quantity squared. Chain rule with quotient rule applied. Okay, this time we have h of w is 5w cubed minus 7w to the 6th power times w to the 1/3 power. So we're going to use product rule. And don't forget that product rule is always in play. We have a 1 and a 2. So that says first to the 6th power times the derivative of the second, which is going to be 1/3 w to the negative 2/3, right? Because I'm subtracting 1. 1/3 minus 1 is negative 2/3. Plus the second times the derivative of the first. Now the derivative of the first is going to require chain rule. So I have 6 5w cubed minus 7w to the 5th power times the derivative of what was inside of that, which would be 15w squared minus 7. Okay, this is ugly. Nevertheless, that's the derivative. I'm just going to leave it like that. All right, this time we have h of u is arctan negative 3u over log negative u. We got to remember what the derivative of arctangent is. Or another way of saying that is tan inverse. The derivative of tan inverse is 1 over 1 plus x squared. Okay, now why is this true? Well, I don't have time to cover that in this video. Just for this moment, just take my word for it that this is the truth. Okay, so when I take the derivative of h of u, the first thing I have to do is quotient rule. So that's going to be log negative u times the derivative of arctan. So when I take the derivative of hu, I'm going to have to use quotient rule. So that's going to be low, which is log negative u, times the derivative of the top, which is going to be 1 over 1 plus negative 3u quantity squared, times the derivative of that, because this is chain rule. So that's going to be times another negative 3. So I'm going to put that in the numerator there. Minus arctan negative 3u times the derivative of log negative u. Okay, so we said the derivative of log was 1 over ln 10 times 1 over u. So this is going to be 1 over ln 10 times negative u. Chain rule says times that, which is going to be negative 1. So actually, these negative 1s and the negative u cancel out. So I'm just going to leave it like that. And then this is all over the denominator squared, which I'm just going to write over here at the end as log negative u to the negative 2 power. How'd you do on that one? That's a tricky one. Hopefully it made sense. Okay, we're moving on. KV, this time we have an arc sine. The derivative of arc sine is going to be 1 over 1 minus u squared under square root. 1 over square root of 1 minus u squared. Chain rule says times du dx. So this time, if I have the derivative here, I'm going to have to use product rule. It's going to be negative 8 times the first, which is arc sine v, times the derivative of log of v to the 9th plus 6. So that's going to be 1 over ln 10 times v to the 9th plus 6 times the derivative of v to the 9th plus 6, because of chain rule, 9v8. Okay, that's 1 d2. So my d2 required chain rule. Now my second expression here is I have log of v9 plus 6, because that's 2, times the derivative of the first, which is going to be 1 over square root of 1 minus v squared. Okay, and this is all being multiplied by negative 8. Very ugly. Let's just leave it like this. But hopefully you can see where the derivatives are coming from. So again, this is 1. All of that is d2, which required chain rule. And then here we have 2, and there we have d1. Okay, next we have m of t is log of negative 5 arc sine t minus 8 arc tan t. Okay, so here m prime of t, log, we have to say 1 over ln 10 times all this stuff, arc sine t minus 8 arc tan t, times the derivative of what was inside. And so the derivative of what's inside is what we've learned earlier. Arc sine is going to be, we're going to have negative 5 over the square root of 1 minus t squared. And for arc tan, I'm going to say minus 8 over 1 plus t squared. So here we're just applying chain rule. And it looks ugly, but that's okay. It's still the same thing. Similarly with nw, instead of doing quotient rule this time, I'm going to write this as arctan negative 8w times log of negative 4w to the negative 1 power, and I'm going to use product rule this time. But quotient rule would work. So I have n prime of w equals first times the derivative of the second, which is going to be, careful, we have to use chain rule here, negative 1 times log negative 4w to the negative 2 power times the derivative of what's inside, which is going to be 1 over ln 10 negative 4w times the derivative of that, which is negative 4. So notice that the negative 4's are going to cancel, and so I end up with 1 over ln 10 times w. Okay, so that's 1 d2. Now I need to say 2 d1. So 2 is going to be log negative 4w, all to the negative 1 power, times 1 over the square root of 1 minus negative 8w squared times the derivative of negative 8w, which is negative 8. And I'll just put that in the numerator. Okay. Again, an ugly expression, but here we are. We got it. All right, y of t, this time is t squared e to the t cubed power minus t. So now when I take y prime of t, I have to say first product rule again. So I have t squared times, now the derivative of 2 is going to require chain rule. That's e to the t cubed power times the derivative of the exponent, which is 3t squared, plus e t cubed times 2t, and then the derivative of t is 1. So right here is where I have product rule. So I can clean that up a little bit, just maybe factor out e to the t cubed power out of everything, and I have 3t to the fourth plus 2t, and then all that minus 1. Great. Now we're going to move on to some implicit differentiation. And the thing about implicit differentiation is that if I am taking the derivative of y with respect to x, I have to treat y like it's a function of x, not just a variable itself. So the derivative of y squared, for example, requires chain rule. That's going to be 2y times the derivative of y, which will denote y prime, or dy dx. So when I'm taking the derivative of this expression here, I want to take the derivative of both sides. So the derivative of y to the 5th power is going to be 5y to the 4th y prime. The derivative of 3 is 0. On the other side of the equation, the derivative of negative 3x to the 5th is just good old-fashioned power rule. So that's going to be negative 15x to the 4th. And then cosine y, its derivative is going to be positive sine y times y prime. Now, from this point, you've got to solve y prime equals. And the way to do that is get anything that has a y prime on one side of the equation and any term that doesn't on the other. So I'm going to have 5y to the fourth y prime minus sine y times y prime equals negative 15x to the fourth. This allows me then to factor out y prime out of both of those terms, and then so I can divide, and so then I can divide both sides by all of this, and I end up with y prime equals negative 15x to the fourth over 5y to the fourth minus sine y. And this is the rate of change of this implicit function at any given point xy. Let's try some more. Okay, this time I'm taking the derivative of both sides, but notice here this is going to require product rule because I have two things being multiplied together. So the derivative of 0 is 0. The derivative of 2x sine y is first times the derivative of the second, which is cosine y times y prime. And then plus the second, which is going to be sine y, times the derivative of the first, which is just 2. And then the derivative of 2e to the x is 2e to the x. Just like last time, anything that has a y prime in it, get on one side, everything else on the other. So I'm going to move over negative 2e to the x minus 2 sine y equals 2x cosine y times y prime. And now, since I have a y prime factored out on my right-hand side of the equation, I can just divide by that. And notice everything has a 2 in it, so I'm going to go ahead and divide out the 2 as well. So I end up with negative e to the x minus sine y over cosine y. And that is your y prime. Let's try another one. So this time I have negative 4e to the x equals negative 4y sine x. Let's go ahead and divide both sides of this equation by negative 4. Okay, so now when I take my derivatives of both sides, the derivative of e to the x is e to the x. Y sine x is going to require product rule. I have first times the derivative of the second, which is just cosine x, plus the second, which is sine x, times the derivative of the first, which is y prime. Get everything with y prime by itself. So I have e to the x minus y cosine x equals sine x y prime. So I can divide both sides by sine x, and I get y prime by itself. There's my derivative. Another one. Okay, so here we're going to take the derivative of both sides. We get 0 equals negative 12 x cubed plus 21 y squared minus 2 negative sign, so it's going to be plus 2 sine y times y prime. The derivative of 7 is 0. Same rules, get everything with y prime by itself. So I'm going to have 12x cubed minus 21y squared equals 2 sine y times y prime. And then my y prime, I can just divide both sides of the equation by 2 sine y. I get 12x cubed minus 21y squared all over 2 sine y. Awesome. All right, now this next one. Y equals 2 to the x power, y equals 2x to the cosine power. Now we can't use power rule here. We have to use something called logarithmic differentiation. And the trick is I'm going to apply the logarithm to both sides of this equation. And the reason that works is because the logarithm property says if I have something in the exponent inside a logarithm, I can bring that out up front as multiplication. So this becomes cosine x times ln 2x. And that's a derivative I can take with product rule. So now I take the derivative of both sides. The derivative of ln y is 1 over y, careful, implicit differentiation, y prime. On the other side of the equation, I have first times the derivative of the second, which is going to be 1 over 2x, times the derivative of that, which is 2, so I just end up with 1 over x, plus ln 2x times the derivative of cosine, which is negative sine x. So now all I have to do is multiply both sides of my equation by y. So I get y equals, we'll say cosine x over x minus ln 2x times sine x. And then I'll just replace y with what y was, which is 2x to the cosine x power times all this other stuff. And you can really write the sine and ln in any order you want on that second term. Now we just went through a lot of derivatives really quickly. Hopefully you learned something, got some practice. Keep working at it. Go back and watch things, refine it, leave comments, ask me questions. I want you to succeed, but it takes time and investment. I hope this helped. I look forward to seeing you again. Thanks for watching.